Hi everyone, this video goes with the urinary system, and we are going to look at the process of making urine. So urine formation is a three-step process. It includes glomerular filtration, tubular reabsorption, and tubular secretion. We're going to go through each of these steps in detail. We're going to start with glomerular filtration. And so we've learned that the functional unit of the kidney is the nephron, and the nephron includes the renal corpuscle, which has the glomerular capillaries and this capsule, and then the tubule, which is broken down into the proximal convoluted tubule, the nephron loop, and the distal convoluted tubule. So glomerular filtration happens all in here, that renal corpuscle. It's a passive, non-selective process. So what that means is that whatever is inside these capillaries that will fit through the spaces in the endothelium and it has the appropriate charge will be pushed through into this capsule and become filtrate. The main pressure here is hydrostatic pressure from the blood inside the capillaries against the capillary walls. So the capillary walls of the glomerulus are made of fenestrated epithelium. And so whenever you see fenestrated, fenestrated means like a window. Okay, so fenestrated epithelium is epithelium that has relatively large openings. There's also a basement membrane, and the basement membrane is negatively charged. And that negative charge to the basement membrane prevents the protein anions that are inside the blood from getting out and keeps those proteins in. And then there are also podocytes or podocytes. Podocytes, that means foot. Pod means foot. And so these are like these foot-like appendages that create little slits that things can kind of be filtered through. So the filtration membrane has, again, fenestrated epithelium, so large openings, negatively charged basement membrane, which prevents large negatively charged molecules from going through, and then podocytes, which create kind of filtration slits that substances can move through. All right, so back to glomerular filtration. Glomerular filtration is dependent on those same capillary pressures that we've already learned about. So hydrostatic pressure, remember the pressure of blood against the walls of the capillaries, is 55 millimeters of mercury. So that's pushing, like the fluid pushing against the glomerular walls. And then we have the hydrostatic pressure of the capsule, and that's only 15 millimeters of mercury. So just looking at these two, the pressure is definitely pushing out. But we the filtrate doesn't have any proteins in it, so those capillaries have a lot of those proteins, those plasma proteins left in it, and so remember back to the colloid osmotic pressure, and that's the pressure, it's the pull of the proteins in the capillaries on the fluid that's in the capsule. And so that pull is 30 millimeters of mercury. And so when we add that all together, the pressure going out is higher, right? So we had, let's see, 55, 30, 15. So 55 is pushing out, 45 is pulling in. So 10 millimeters of mercury of net filtration pressure, right? So that's why we get the net movement of filtrate into the capsule. Okay. Um, and we can also look at the glomerular filtration rate. And this tells us something about the health of the kidneys and the health of the glomerulus, right? Um, so it's the units are volume per minute, okay, milliliters per minute, and it's related to net filtration pressure, the total surface area of the capillaries, and filtration membrane permeability, what is able to go through. Okay, and it again, it's a measurement of the health of the kidneys. Um, we can find out if there's kind of protein damage, that kind of thing, by looking at the glomerular filtration rate. Um, there's three ways of regulating the glomerular filtration rate. Um, and so there's renal autoregulation, which is looking at the degree of stretch um, of the vessel that brings blood into the glomerulus, the afferent arteriole. Um, and so there's tubuloglomerular feedback mechanisms. So tubulo is talking about the tubule, glomerulus is the glomerular capillaries, um, and the feedback is going to respond to changes in the rate of filtrate flow going into the tubules. So that is renal autoregulation, auto meaning self here. And then we have extrinsic neural mechanisms, um, things that adjust um, blood pressure. Stress can affect GFR, um, you know, all those autonomic nervous system things that we've talked about in 217. And then we have the renin-angiotensin-aldosterone mechanism. And remember, renin is released by the kidneys when the kidneys are exposed to increases in systemic blood pressure. Okay, so those are the three ways we regulate the glomerular filtration rate. And the next thing we're going to talk about is tubular reabsorption. So in the glomerular capsule, right, we've just created this filtrate, but that filtrate is going to go into the tubule and kind of travel throughout. But just after it gets into the tubule, nearly all that filtrate is reabsorbed, and that means going from the tubule to the capillaries that are surrounding the tubule. Okay? And each part of the tubule is able to move different substances. So when we look at the PCT, that's where most reabsorption occurs. So amino acids, glucose, a bunch of different ions, lots of water gets reabsorbed in this area. The descending limb is where water can leave. The ascending limb is where ions can leave. And then the DCT, the distal convoluted tubule, it actually changes its permeability depending on what kind of hormones are available or around. So, antidiuretic hormone is going to tell the DCT to pull up more water, bring more water into the capillaries. Aldosterone is going to uh, result in more dilute urine. And then atrial natriuretic peptide is going to tell the body to dump salt. And when you dump, so that's going to create also more concentrated urine. So again, this is tubular reabsorption, and the amount and the components that are reabsorbed varies based on where you are in the tubule. The proximal convoluted tubule is where the vast majority of reabsorption occurs. Water in the descending limb, salts in the ascending limb, and then the DCT changes permeability based on the hormones that are around it. Um, Something to think about here is that all of these things, or many of these things, are transported with transport proteins. And anything that's transported with transport proteins, um, you know, only the number of proteins we have is going to limit the amount of transport that can happen. So we have this concept of transport maximum, and transport maximum is saying that um, if the amount of a substance exceeds the number of transport proteins that are available, we've hit the transport maximum, and any excess is going to come out in the urine. Okay, so this is one of the ways that we get glucose in the urine, right? If we have a lot of glucose in our bloodstream, when the glucose is being reabsorbed, we might not have enough transport proteins to move that back into the bloodstream, and so the excess ends up coming out in the urine. And the last step is tubular secretion. So I'm going to spend a little bit of time over here because this is a very simple photo or simple illustration, but I think it shows you a bunch of what's going on. So blood comes in the afferent arteriole, it goes into the glomerulus. This is where the filtrate is formed, and then it's going to leave the efferent arteriole. And then we have the peritubular capillaries, which are the capillaries that wrap around the tubule. Okay, so filtration formation happens, and then reabsorption happens, which is when 99% of what's just been turned into filtrate gets reabsorbed into the capillaries, those peritubular capillaries. And then after reabsorption, there's tubular secretion, where substances that are in the capillaries get sent back to the tubule. Okay, so solutes can move from the capillaries back to the tubule, any solutes that are in excess. This is also a mechanism of controlling blood pH. So tubular secretion is the movement from the capillaries to the tubule. Tubular reabsorption is the movement from the tubule to the capillaries. And at the end, we end up with urine. And so that urine is going to travel through the medulla of the kidney into ultimately the renal pelvis and the ureters. And the components of urine in a healthy person, it's pale to deep yellow, it's slightly acidic, it's 95% water, 5% solutes, mostly like salts and urea. But we can use urinalysis to identify things like proteins, pH, glucose, bilirubin, white blood cells, that will give us an idea if there's underlying disease or infection happening.